Hi class, we meet again in this video. I'm going to show you a few examples on how to solve your problem regarding your isentropic efficiency on your steady flow energy device. There are basically three devices will be shown in this series of video, which are the nozzle, the turbine and the compressor. And I'm going to show you each of these examples for different type of working fluid. It's either vapor or your ideal gas. But before we move further, let us recall back what we have learned so far. So taking for example, you have a turbine where turbine is producing work, which is work out, and this is your high pressure towards your low pressure, and the working fluid inside your turbine is steam. So let's translate this diagram into your TS diagram. Okay, so you have a TS diagram because your working fluid is vapor type, so it's going to change phases. Now your diagram will be your TS diagram. So vapor, you are going to have this bell curve, so it's working on two pressure line, one is low and another one is high. So your turbine now is working in from pressure high to pressure low. So basically this is obeying your second law, which is from high pressure to low pressure. So what does isentropic process mean? It means that you are having the same S value, which is if you project this downward, so your S1 here is going to be the same with your S2. Why? Because during the flow of your steam from the inlet to this outlet, right, labeled as 1 and 2, right, so basically there's no friction on your working fluid. So when there's no friction, as the steam flows from here to here, right, so since there's no fluid friction, means that there's no heat addition. That's why you are going to have this entropy value is the same at the inlet and your outlet. This is like having an ideal thing, right? Or in your dynamic, the condition is no slip conditions, where you don't have a friction force on the opposite directions. But in this case, in your thermodynamic case, there's no fluid friction in your in your turbine. So you are not going to produce any heat due to your frictions, right? And therefore your value of S inlet and your S outlet is going to be the same. Unfortunately, in the actual plant, right, your flowing fluid will always going to have a fluid friction. So therefore, it's going to generate some heat, and eventually it will affect your S2 value, where this is going to be your actual, right, because there's heat generated due to this fluid friction. So heat is going to be generated, therefore your entropy S, because entropy unit is in kilojoule per kg dot Kelvin, right, therefore your entropy at the inlet is not the same with your outlet anymore, because in actual cycle there will be a fluid friction that contribute to your heat. Therefore the value of your outlet will be increasing compared to your 1. But the ideal condition, what we call it as isentropic process, where there's no fluid friction, so there's no heat, therefore your inlet of S is the same with your outlet of S, right? In this isentropic process, we are going to focus on these 3 devices, which is your nozzle, turbine and compressor, because from this onward, the chapter will be on the application part, where you are going to have a steam power plant in next module, and in another module you are going to have a gas turbine plant. So it is important to try to analyze on this device first, because you need to determine a different working fluid. Alright, so in the case of your steam power plant, so your working fluid will be water, whereas in your gas turbine plant, this is going to be your air. So we will see what is the effect of your isentropic process, isentropic efficiency on your device in these 2 systems, right? So I hope you will stick with this isentropic efficiency series from nozzle up to compressor. Thank you.